Hey, hello, welcome, and good morning, guys. Okay, let's start the session. So, today's topic will be an interesting one. So, with OpenShift, how you can run the Windows workloads. So, without further delay, I will start the session, or do I need to wait for another 1 minute, maybe, so that you guys also can refresh yourself? So, 11:31, I will start the presentation, and we will go with the slides, the interesting slides. All right. So let's start the session. Let me share my screen. Hope you guys can see my screen. All right. Okay, let's start. So today's topic will be like running .NET application in Kubernetes. What? You are going to run a .NET on Kubernetes? Let's see how. So me, Karthikeyan Mutramlingam, solution architect from Red Hat, Malaysia. So what are the topic we'll be discussing today? So first will be your introduction, like introduction to .NET. So I will not explain much about that, but I will give you a year and then the version of .NET, those kind of stuff, and then .NET framework as container, and how you can host your .NET framework with OpenShift for Windows container, and how you can mix your workloads with Linux and Windows. I will show a demo on that also. So at last, we'll have a Q&A session. So in that, we can discuss furthermore. Okay, let's start. So here you can see um, the versions listed below, and then the current version is 4.8, which is the latest .NET Framework version, which is recommended. And there is a note which was given by Microsoft saying that .NET Framework 4.0 is the latest version, and further after 5.0 it will be .NET Core applications. So Core is like you can run the application either in any of the platforms. So for that, Microsoft has given preference for .NET Core applications. So today we will be talking about the old guys, which is .NET Framework 4.8. So most of the organizations are using the backend and then the core services to be running in .NET Framework 4.8. So in order to address their issues, we will be seeing how we can easily put it on the Kubernetes and then scale it, and then you can reduce a lot of time and effort for that to host your applications. Okay, so here is a conversation between grandma and how it goes. Let's say, see the grandma's expression, .NET framework on Kubernetes. Really, she is surprised, kind of, right? So, if comparing with your organization, let's see on the other side, I still use .NET framework. This is your old core application, which I can really simulate, like compare this. So you see the expression of a grandma, and you see the other side, the skeleton, which is using a .NET framework still. And our hero comes in. So I will assume that this is our Kubernetes engine, and the upright guys are the old usage, the .NET framework application, which is running in monolithic architecture, those kind of guys. So I can see that, okay, see, I can run .NET framework on Kubernetes. He's like in a field like, okay, how you are going to do that. On the other side, our hero is very cool, and then he's explaining, okay, I can still run the application. Let me show you how. Let's see. So .NET Framework with our Red Hat OpenShift for Windows container. So you see why you need a Windows container. A Windows container will be very helpful for the developers to adopt your microservices by running this Windows container. So Windows presence is still a very great demand in the operating systems in your data centers, the old data centers. And then, as I said, the mixed workloads, right? You can run side by side with your Linux container. And then for the .NET app development, right, it has been widely used for application development. And also, till now, the older application are trying to see as a future view how they can migrate or how they can run their workloads with our latest technology to compete each other. Okay, how you can mix your workloads? So you see, Red Hat OpenShift virtualization. So this, and then Red Hat Enterprise Linux Core OS, and then on the other side Windows Container. So let me give you a tabular column, which will give you a brief on this. So you see, so these are the use cases for your Red Hat OpenShift features, and then on the comparison of your diagram. So virtualization, Core OS, and then the Microsoft Windows, and then Linux container. So you can see the tabular column. So in order to rehost your system, so OpenShift virtualization will be a great fit. So it is like lift and shift your Windows-based virtual machine to OpenShift. So it is like no benefits of your containerization. So in order to refactor, a Red Hat OpenShift support for Windows container will be very helpful. So you can containerize and then run your traditional .NET framework application on Windows Server containers. And also you can deploy that into a worker nodes, and then you can host it on your OpenShift. So great benefits are like containerization, and then it also involves some of the Windows container ecosystem, and then the most supported Windows Server version is 2019. So in the later slides, I will show you what are the base images, which is great fit for the Windows worker node to run. And then re-architect is another factor, and then rebuild is another factor. So all this rehost, refactor, re-architect, rebuild has to be addressed. And then in this slide we will be seeing, okay, how you can address your um, older machine or older architecture to be hosted and then perfectly running in your current compete environment. You see, this is a Windows machine configuration operator, which is available in the OpenShift. So don't get surprised why I put this slide suddenly. So this is a slide which gives you an idea how you can port your Windows worker node to be running on your Kubernetes engine. Kubernetes engine is a community one, and then the enterprise one is our OpenShift. So I'm not going to give you a name or a mark on my OpenShift product, but this operator, why I have shown in this slide is this one you can easily install in your OpenShift. So on the demo session, I will show you where you can find this community Windows machine configuration operator, and then Windows machine configuration operator as a trusted and certified one in our OpenShift. So this is the OS to target. So .NET Framework 3.5 to 4.8, which is the current version, and then the latest version of the framework, as it will be supported. So this is the version, this is the OS we will be targeting. And then on the below, it is the latest one, which it can run on Linux or Debian or Windows. So on the next slide, you can see .NET Framework 3.5 and 4.8, and above the legacy .NET can run on your Windows 2019. And then .NET Core, which is a modern, which it can run on your Linux container as well. Okay, this is the best and supported base image for your Windows worker node to run. Okay, this decision tree can show you a brief. Okay, on the right hand side, on the left hand side, you can see a .NET framework and then the .NET Core. So if your .NET framework is compatible version, then you can go to your Windows container, and then you can host it in the Windows nodes. If it is an incompatible version, right, then you have to port it to .NET Core application, and then you can host it in either a Linux node or a Windows node. The second option will be a lift and shift. So it is like which I have shared, right? The rehost and refactor. The refactor kind. The rehost is the one which I'm talking about, the lift and shift. So you can host by just picking up and then hosting it in a OpenShift virtualization environment. On the below decision tree, you can see the .NET Core application, which either it can run on Windows nodes or either on our Linux nodes. So this decision tree gives you a clear picture on how you can approach the product and where you can host it, right? Hope you guys have understood this. Okay, without further delay, I will go to my demo. So first I will show you the demo steps and then the demo what I'm going to do. So first I will show you where is the operator and how do you install it. And then the conversion steps to a Docker image where my front-end application is in my local laptop, which is already converted to a Docker image and then hosted and then pushed to the OpenShift environment. And then how you can mix your workloads with the Linux and Windows. Let's say your front-end application is running in Windows, and then your backend, the database, and then the services are running in your Linux workload, Linux nodes. So I will show you a differentiation of where it is running and where it is hosted. Okay, and then so this is a place where you can find your Windows operator. So just a snippet, so you can have a idea in your mind. Later, when I'm showing it in the demo, right? You can see, okay, this is where I have shown in the snap. So this is how you can verify whether it is installed successfully in your OpenShift operator. So these are the conversion steps which I've took from public GitHub. So you can see what's the first step is containerization your application through your Visual Studio 2017 tools for Docker. So in this option, you will have from your file menu, you can go to your conversion tab, convert to your Docker image. So this is a simple step which with Visual Studio, so which only you can do it on Windows machine. So since I'm using a Mac, I cannot do this on the live. And then the second step will be manually you have to add your Docker files, and then you have to use your Docker CLI and then run and then convert it. And then the third is you can containerize like image to Docker tool. There is a tool available, open source tool. You can use that tool to convert the application to the Docker file. Fine. Okay, so this is like these are the worker nodes where you can find the OS images, those kind of stuff. So let's jump to the demo. So far, any questions from your side so that I can understand? Is it too fast or too slow? Any comments or any feedbacks? You can let me know in the chat so that I can address to that. If no questions, then I will go to the demo. Okay, so first, as I have shown in the slides, where you can find the OpenShift Windows configuration operator. So once you log into your OpenShift console, you can see a tab like either go to a developer view or an administrator view. Go to the administrator view, and then under administrator view, you can see operators. So in this operators tab, you drop down the list and then pick open operator hub. So under the operator hub, you can see a multiple components which is available already. So these are certified, and some of them are community version also available in it. So here you can simply search for Windows. So you can see a community Windows machine config operator, which is the one which I have shown you already. So you can see this is how just a click and then you install, the operator will install automatically. And then this is the one which we will be showing in the demo. So Windows machine config operator. So these have some prerequisites. You can read out the prerequisites, and then a default naming will be there. The OpenShift Windows machine configuration operator. This will be the namespace which will be available. So this one I have installed already for you. So just click on the install, it will install you with some of the default namespaces. You can see the OpenShift Windows machine configuration operator. So under this namespace, go to the you can see as an install one. So how do I check how what are the operators has been installed earlier? So go to install operators. You can see a status to be succeeded, and here you can see this has been installed successfully. And these are some of the detailing and explanation given, and then the YML has been explained here. So we can go through this. Fine. So, and the second slide, what I have shown you is this one. So I have addressed to this. And regarding this, I'm not going to address these steps, but I can show you the code which is available and which is already converted to be a Docker image. So this is the code which I'm going to talk about. And let me show you which worker node is using the Windows. Go to compare and nodes. You can see a multiple list here. So first I will show you in the UI. So UI, you feel like, okay, I need to open and then see which is my Windows node. So you go inside and then see on the details. You can see this OS image is a Linux core. So this I have to click on everything and then see one by one. So it's like manually you're going and entering and then putting in and then checking the OS, right? For this, I will show you some command lines so that you can see it very clearly, and then you can see it which node is using Windows. So you go to your command line. So before that, you have to connect to the OpenShift. So so this is how you connect to. So once you click, it will ask you for the credentials. So once you enter the credentials, you will have your token displayed. Just copy that token and put it in your terminal. So you can see it is connected. So once you connected, to verify it, you just put on OC projects or OC info, anything. So it will display what are the projects available. So you can verify that, okay, it is connected and it is connected to the default project, default namespace, which is available. Okay. So here, you can verify the Windows node. Uh, so OC and then get nodes, hell, Kubernetes .io/OS is equal to Windows. So you can see the name 156 is a Windows. So you can go to the 156 and see a Windows Server 2019 data center. So this is how you verify your Windows worker node or naming. So in order to see in your command line itself, just append O and then void. So you can see a detailed information. Let me You can see the OS image name to be here. All right, fine. So let me copy this, since later you will need this for your verification. So let me increase this. So this is our Windows, okay, and then the rest container rest nodes are the Linux which is running in. All right. So this one I have addressed it, and then let me go to the mixed workloads and then show you how you can combine and then how you can run your mixed workloads in this. So let me go to the sample application. So which is um, which is the NetCandy Store, so which is available in GitHub itself. So you need to download, and then you can see the app codings to be here. So some of the configurations are already written here. So in this, go to create database. This will be your first step. So in order to host in your OpenShift, let me show you some 7 to 8 steps. You can follow these steps, and then you can successfully host it in your OpenShift without any thing you need to additionally add or something. You already a terminal, and then you can run your sh command, and then it will create automatically for you. So I'm not running this directly, but I can show you how do you verify after installing. Okay, so you can see delete command here. So if existing name is there, it will delete and create a new one for you, and then it pulls the source to image from GitHub user content, and then it creates SQL with a password. So you can see a command here, create, and then candysb.sql. So these are the files which is available already here. So first it will create a candysb, and then add to cart. So these are some of the tables which is required for the application to run. So before that, let me show you the application so that you can be very clear on what I'm showing in the command or in the project. So here, this is my application. So this is a simple e-commerce application. Sorry, my internet is too slow today. I'm not sure what had happened to my internet. So this is the e-commerce website. So here you can search for the chocolates, and then you can add or log in. So either if you want, choose one chocolate. So you can see add one box. So this is simple. This is like your online shopping kind of. There is a Choco, some website is there, and then cookies website is there. So you can see the cookies biscuits diagram there. You click on the cookies biscuit, add to your box. So this is what exactly which we are going to host it in our OpenShift. So this is already OpenShift. This is already hosted. The front end is running in Windows Worker Node, and then the services. Let's say if I'm clicking on the add one box to uh, cut. So this services are running in your Linux. So this is like mixed workloads. Okay, so this is the application. So stick to your mind so that when I explain about the code, right? So you'll be getting a clear picture of what I'm going to do. So you can see add to cart, right? So this is a SQL query for the add to cart and calculate or create shopping cart. So these are some of the tables which is required for the application to run. So first step is your create database. So we will create the base or a foundation for your application. So once you create your database, then you can move to your wrap up of your JSON file. So preload sh will be there. So what it does is it pulls your Windows machine node name. So this is a name. So this command exactly pulls this name and then store it in your path. So and then later we will load the preload YML, right? So during this time, this internal node will be pushed to your code, and then it imports your application to your OpenShift. So first step will be, let me summarize your steps. So first steps will be, oh, sorry, I forgot to mention that you have to create a project with the name of NetCandy Store. So how do you create a project? You click on the create project, put the name, and then you click on create, let's say a test one, and then you create, it will create automatically. So this is how you create a project or your namespace. Okay, first you need to create a NetCandy store as your namespace, and then in your project, right, you go to OC get, and then OC project, and then your project name, let's say test one, then you can go inside your project. Fine. And then the second step will be you have to go to your create database. So this one, once you connect it to the OpenShift, you go to your sh file, which is available inside one path. So it is under downloads path. So you can go to cd download. So cd NetCandy main, and then inside this you can run sh your create underscore database sh. So it automatically creates for you. So since I have created and imported some of the test examples there, I'm not going to run or rewrite this. So once it is installed, I will show you the verification steps alone. Fine. So once you created your database, then you have to prepare the steps which I have showed you just now. So preload your Windows name. So what it does actually, you can run this command here. So you see, sorry. So what it does actually is it gets the name and then it sticks to your Jack Sparrow, which is the name which I've given here. So you see the compute naming here, right? So this is a name which I have exactly copied here. So either if you are running in a different OpenShift environment, this command will be helpful to retrieve the Windows name exactly. Or you can use the earlier command which I have written here, oc get nodes -l kubernetes .io os will be this one. And with this command also you can verify what is the Linux work nodes running in. Okay, so if you click on this, it will give me around 4 nodes running in. So these are some of the Linux code nodes which is running in. Okay, once you prepare your preload statement, then you go to your preload YML. So this actually runs your um, um, existing images and then push to your OpenShift container, OpenShift worker node container. Once you have done that, you have to apply the NetCandy Store YML there. So this YML will have your exact services path and then your microservices URL. You have your container image in your QA, so it will automatically load the latest image to your worker node. Fine. Okay, so first step will be your create your database. Second step is your preload YML, and then third is your NetCandy Store YML, which is like just you need to create like OC apply F and then YML. Just click on enter. It will apply the settings for you. And then last will be your get your backend services to be applied in your OpenShift. So these are some of the steps which you need to follow once you download the core. Let's see how you need to verify it. So here you can simply go to the nodes which I have shown earlier on your administrator. Go to your compute and then nodes. So what is the number for the Windows? You can go to your Sublime and then 156 is your Windows. Go to here and then you see your ports. You see your front-end application which is running in Windows ports. Fine. And how do I verify that my backend services are running in your Linux? So go to your command line. Sorry. So go to your command line. Get nodes mm, oh, sorry. We are going to verify the Linux nodes, right? Which step I mean? Pods. Okay. Get your pods and then hyphen and your namespace. And then later you need to enter hyphen L app. App will be your get categories. And then enter wide. So here you can see 170 is used. Go to 170 and then list the pods here. You can see get categories here. So which is running in your Linux coin. So this is how you verify. So where my MySQL DB is deployed, you can also verify that. So here deploy EPM. One config SQL. So let me go to pods hyphen L NetCandy Store hyphen L deployment config is equal to. So last time also I made a mistake. So DEPLOY. Mhm. Oh, okay. So 170. So this is also using the same Linux core nodes. So you can see the front end application is running in your Windows worker node, and then your backend services and your Linux is running in your uh, backend services, and MySQL DB is running in your Linux node. So here, some of the features which I will show you. So I showed you the application. So this is just you can add and then you can run on playthrough. So this actually runs in your. You can see your backend bundles, those kind of stuffs, or if you need to put any commands, you can add it in your studio code. Go to your application, you can add the commands, or you need to add some of the code changes, you can do it, but you need a Windows machine to import it from to a Docker image, or you need the three steps which I have informed you. Fine. So that's it. Um, I hope everything has been covered. Okay, everything has been covered. So let's say if you want to explore more, you can scan this and then you can explore more, or you can go to the public website. You can see OpenShift and then Windows container. So you can see the supported and then the steps to be on available in your public itself. So you can see the diagrams and then the factors which I have explained. And then these are some of the examples. So you can explore by yourself by accessing on your public website. Fine. So next will be the Q&A. If any questions, you can ask me. Any questions so far? If no questions, then we can close and we wait for another 10 to 15 minutes. Let me show you some of the examples or some of the features available in already. So you can go to your overview. You can have your current activity status and your CPU, memory, and those kind of details will be available as they have explained as the earlier sessions will be addressing regarding the OpenShift environment and OpenShift usage and what are the facilities available and how you can opt OpenShift. And this is the operator hub which I have shown you. So just a quick recap. So here you can find the trusted components available here. You can choose and then you can run in your OpenShift. So you can explore what are the things available here. So this is how you verify once you have installed it, and the way your nodes will be presented, the worker nodes will be presented under compute and nodes. So since multiple nodes are running in, you can filter based on the command, and then you can get the name of the worker name of the worker node which OS you are targeting in. And also once you go inside, you can verify which pods also running in your worker node. That's it. Thank you guys. Okay, I have a question here. Can you scale your Windows container? Yes, you can do that. There is a step separately available in the website. So, in order to scale your Windows worker node, you cannot directly do it from here. So, you need to have an additional steps for scaling up. So, I can show you the scaling up things. To answer your question, yes, you can do that. There is an additional steps to be done for your scale up that you cannot do like directly go to your developer thing and then you click on the application, you go to the pods, you won't see like you click on 1 2 3 and then you can do your application to be scaled up, but to do from your operator there is some other steps to involve so that you can scale up your operator like in your different clusters you can manage that. Is this answered? Okay. Any other questions? If no other questions, I will stop sharing. Thank you guys. Thanks for attending the session and hope this one is very useful, and I will require your feedbacks later. What to improve and what are the additional points I need to add on when presenting. Thanks guys. Stop.